Let's do number 12. So this is the one where they actually give you a current, but one of the resistance is unknown. And we're trying to find the current through this resistor over here. So this current here is, and I call it I1, is equal to 0.03 amps. So let's use our junction rule. So I actually ended up drawing I1 here to the left, I3 going down, and I chose I2 to go this way actually. So this was just random picking. And with this I can do my junction rule, whatever goes in equals what comes out. This time we have 1 and 3 going in. So I1 plus I3 going in, and I2 going out. And now we need to use the loop rule. So this is where, for this particular example, where you can do this problem the easy way or the hard way. So I'm not going to do it the hard way, but I will tell you which way is the hard way. The hard way would be to pick these two inside loops. Right? If you picked these two loops, no matter which way that you go around them, let's say you go this way and you go this way for this one, when you add up all of your potential differences, then we don't have a value for this resistance. So I'll do 1. Let me start it here. I'll get 30. And then here I'm going with the current because my I2 is going this way. So minus 500 times I2. And then plus 15 here because I'm going from negative to positive. Then here I'd have minus R times I3. And then I'd be back to where I started, so equals 0. And then I would do the same thing for here. I'll just go ahead and do it real quick. So let's say I'm going to start here, and I'm going clockwise again, so I'm going to get plus 10 volts. I'm going with I1, so minus 400 I1. And then over here, I am going against the current because I'm going up, so that would be plus R times I3. And then I would have minus 15 because I'm going from a positive to a negative. And then back to 0. So this is the hard way, which it ends up it's actually not too hard because when you solve this system of equations, instead of having 3 unknown currents, we actually know what I1 is. So you could actually plug I1 in here without having to do any substitution. Since you just have a number, you could just put this number in I1 and solve for I3. And then whatever you get for I3, you could plug it in here. Wait, sorry, that's not true because you have the unknown R's. What you could do here is with these two equations, you could add them together. And that's the elimination method. If you add these two equations together, then both of these terms cancel out. And then you're left with an equation that has only I1 and I2. Alright, I'm not going to do this. This is the hard way, that you could actually use elimination to get rid of the R times I3. Luckily, the equations worked out this way. And then you could plug in what you get for I1, and you can get I2 by itself. And you wouldn't even need to use this equation. But there's an even easier way, and that is to pick the outer loop. Look what happens if you pick the outer loop. So this is why in class I said, choose your loop wisely. If you choose the outer loop, let's start here. We get 10 plus 10 volts here. And then we're going with I1, so minus 400 I1. And then we're going plus 30 here, from the negative to the positive. And then we're going with I2, so minus 500 times I2. And then we're back to where we started, equals 0. So by picking the outer loop, it's not necessarily the loop that had the least resistors, because it still had 2 resistors, while the inner loops also had 2 resistors. But this outer loop did not have this unknown resistor. So that's why it was easier. So by picking this one, I can actually solve for I2 here. When I get I2 by itself, I get I2 equals 400 I1. I haven't had to do any substitution here, just solve for I2, divided by negative 500. And since I have a value for I1 to 0.03 here, then I can plug that straight in here, and I'm going to get a positive answer of 0.056. So that tells me that the answer is 56 milliamps. And since I got a positive answer, it means I picked my direction correctly. That means it was actually going from left to right through that resistor. So always pay attention to which loop that you're picking. In this case, because there was an unknown resistor, I picked the loop that did not have the unknown. It made the problem easier. Or in general, just pick the loop that has the least resistors, and that will also make the problem easier, that you don't necessarily have to use a bunch of substitution and do matrices to solve for your unknown. That it's not too hard. You only had to use this one equation.